Hello, everyone. We are presenting our final project, the COIL database. My name is Pallavi, and my teammates are Tyler, Madhu, and Vitor. Our client is Dr. Sharmila Udevar from the Global Education team, and their program essentially connects UNC courses with a global partner university, and the students and instructors of this course conduct collaborative activities and foster shared learning. Their team uses Excel as their main way to store their data. And as this is detailed information of instructors and grad students that are part of the program, it can be very messy within their Excel sheets. So they came to us to create a streamlined application with a user-friendly interface that any of their team members can easily edit and use. Here, I will be going through the user interface demo. I am demoing on the local host, but we do have a production environment set up. Here you can see our key statistics bar. We have the departments participating, courses available, participating schools and students enrolled, and all of this data is being pulled from our backend using endpoints. These are the summary reports, started reports, and pages section. You can search through the pages as they're added in. Starting with the schools. If I try to update any of the data within the database without logging in, it's not going to let me. Here we've implemented role-based access. So if I log in using the credentials, I will now be able to update any of this data. So if I were to go back to the homepage and see the participating school count is 55, and if I update the school count by 10, and go back to the homepage, you can see that it's being dynamically updated. Now going into the COIL courses data, I will demonstrate how you can add and filter data. So to add a new row, click the Add New Row button. And if the computer science department was doing a COIL course and we wanted to add that to the database, we just do this and you can filter. And here's our course. And to delete, simply select the row you want and delete. Going back to the home page and into your faculty recipients page, we've also added a functionality to export this data as a CSV file. This is to be able to share any of the reports that they've made and all the filtered reports. So this is the report as a CSV. And then lastly, this functionality is not fully implemented, but we wanted a button that will allow them to star a report after filtering based on their requirements, adding any titles, so faculty. And if they added it and went back to the homepage, we wanted to be able to click back into it and have the filter settings applied. We currently have the model, schema, and the API resource file set up for it, but the front end is not complete. It should be a stretch goal for us, but that is the extent of our UI. And going back to our presentation, this is the video of our front end that we will be sharing in our handoff documents.
The first thing we did when we received this project was to clean up their Excel sheet. This was mainly done by formatting the columns in every sheet provided. Um, so if it's meant to be a string, then it strictly had to be a string or a number, date, etc. Any sort of empty rows where there were required fields not filled, we reached out to the client to clean that up. This was then uploaded to PG Admin, where I was able to make sure that things were listed at primary keys, limit the number of characters allowed for certain columns, etc. This was converted to a dump file and uploaded to our server. Our main tools and IDE used for front end was React and AGGrid. We used React because it was very flexible, it's easy to debug with it, and it has massive library support. AG Grid is very good for dynamically generating data, and there are multiple easily applicable features like filtering, capturing models, etc. We use Postgres SQL because it's reliable and quick, it's easy to deploy, and it's supported by Fast API. We used Figma to show off to our clients what our final product would look like for the front end. And we used VS Code as our IDE because it's simple and straightforward and it has built-in Git tools. The language that we used for our front end was JavaScript, and for our back end, it was Python and SQL. The server where we deployed our data was Carolina Cloud Apps, which is hosted by OpenShift. The frameworks and libraries used, as mentioned before, are React, AG-Grid, Fast API, SQL Alchemy, and Pydantic.
And then I will be going over the back end and APIs. So first is our architecture diagram. So there are some slight changes from the midterm architecture diagram. The front end, back end, and data storage structure mainly stayed the same. In the front end, as Madhu said, we added AG Grid in the front end, which is a popular data grid component designed for web applications, and it was perfect for us to manipulate our large data sets and add that to our front end web interface. Another change from our midterm architecture diagram was the authentication. Originally, we planned on using the UNC SSO authentication, but we weren't able to do that. So we just used a simple header token with a username and password. And we also were able to deploy our database onto OpenShift and have that running. And lastly, we made it so that the admin needs to have, or the team member will be view only because of the authentication with username and password. So the team member will not be able to X or input CSV files or input HTTP requests into the backend just like the admin would be able to. And then next slide, please. Thank you. And then, so this will be the backend models in the top right. That will be the list of our data tables in our database. So as you can see, we have tables like departments, faculty, compile data, grad students, schools. And then for example here, I'll just be going over the models of faculty. So in the bottom left, you can see the SQL structure of the faculty table. And then to the right of that, you can see the modeling that we did in the back end. And then to the right of that is the pedantic modeling of the faculty table so that we can output that to the front end. Next is our API endpoints. So I will still be going over the faculty recipient as a example. So, but for all of our tables, we created all of the endpoints, get, put, post, and delete. We added we added 3 get endpoints for each table to get the table, get the individual ID or row in the table, and then get the largest ID in the table. And then, of course, post to add to the table, put to edit, and then delete to remove. And then this is what the structure of our backend endpoints look like. And lastly, I didn't add it onto the slides, but in our backend for services, we have a compiled quantitative data resource service file and a school department service file that we used that we have queries in there that we call in the back end to help us compile data in our front end.
So for our deployment, um, we deployed to production by using separate Docker images for front end and back end. We also made a production database and dev one separately so that we could make development and testing easier while maintaining the official data protected. It deploys straight from the GitHub main branch. Um, so we had a lot of difficulty, especially in the deployment part, uh, with authentication. Um, so one thing that we learned is we shouldn't break the workflow and start with deployment. So like after we get a basic app running and get basic endpoints for all the methods with authentication, then we can do a deployment because that would give us a lot of time to debug. And debugging deployment is a really time-consuming process. We got to work on reports, but there's some complexity for saving to the database, and it wasn't ready for production yet. Um, Importing CSVs is also a task that was on our backlog, um, but it wasn't essential, but it would still be a pretty great thing to have. But it's a pretty big uh, thing to have. It could almost be a project by itself. So SSO is another thing that we wanted to have. We tried global authentication, and that works in development, um, but it doesn't work in production yet. The next step would be to have a fully fledged authentication system and authorization. And then lastly, our compiled quantitative data. It has all the endpoints it needs and all the models and stuff, all the data, but it still needs to be connected to the front end.
Thank you for listening.
Thank you.